Okay, welcome to SQLite tutorial number 2. Right now we're in the My Web Table View application that we have created. I'm going to go right to the app delegate declaration file. Two methods have been added. With SQLite, you have to be able to copy the database over to the iPhone, the iPod, and so on. And you need the database path to get that path so as to copy it over. If you do not do that, the SQLite database will not be copied onto the iPhone or iPod Touch. These methods have been well established and they work really well. I'm going to go to the implementation file and show you them. They're both instance methods. That negative sign there is an instance. Looking at the first one here, let's look at the getDB path method. It returns a string, which would make sense because if we're getting the database path or the getDB path, we want to return the string, which is the database path. NSArray, we call up the NSArray method or class and create a paths variable and set it equal to the search for path directory in domains class, or actually this is it is a class, and then it has variables in it, the document directory and the user domain mask. Basically what this method is telling you is, look, search in the document directory but in the user's domain and set that equal to yes. That's all that's saying. It's quite simple. It's nothing tricky, but it looks terribly intimidating. The next one that's called up is we call up a string. We're going to call it the documents directory. This is the variable, and we're going to set it equal to the paths variable. Its method's called the object at index. We bring that method up. What we're saying is, look, on the path, call the object at index method and look at index 0. We should find a database there. One database. We return the documents directory, this variable, string by appending, and we're gonna basically return the directory name, and we're going to append this file, which is our SQLite file, to it. So what we're really saying is here, we're looking for the path. It would be like if you were in Windows. Alright, I want the C:/Windows//path, and I want to, in that I should find this database. So it's not the same, of course, in iPhone, iPod apps, but we're returning that path in the beginning, that path structure, and appending to it the database name and .SQLite, the full name. This is used here. Now, if you look at the copy database if needed method, it will look at it. It will create an instance of something called NSFileManager, and it will create a file manager variable and set it equal to the default manager, which is the method of file manager, whatever the default is. We create an error variable. Here's the database path variable as well. This is a string, and this is an error class. We set it equal to self getDB path method. Okay, so we say make our database path equal to whatever this returns, which is what we want, right? We then declare a boolean, a yes or a no, or true false in this case, called success, and we set it equal to the file manager. Now our instance here, we call up the file exists at path, that method, and the database path. So if this file manager and file exists at path database path says I find it yes true, then I have success. If I don't, it's false. Then we have an if loop here. If success is not, or if we don't have success, if we're in a false condition instead of true, then create a new default database path, DB path. set it equal to this NSBundle method, and rather class, and call the main bundle method, and then call the resource path method, and append again the same database file. So what's this saying? If I don't find it here, look and create, alright, a new database path, and look for it in the main bundle, alright, under the resources, which is here, right? That's basically what it's doing. And so what really saying here is this: if it's not on the iPhone or iPod here, copy it from the resources to the iPhone. Once it's done, if you remember what I said, once you do this the first time, what will happen is this Boolean becomes true. It sees it on the iPhone or iPod Touch. And so in order for you to then update this database, where are we? I'm sorry. Hold on. Where? Our database, which is here. I'm sorry. In order for us to update this, we have to delete the iPhone app, and then rerun the application, rerun it from here. What it does is it then defaults back to here, right here. It says, okay, I don't find it on the iPhone, iPod. I'm going to write it from here and pick it up in the resources here. Make sense? So this is why, and people, they copy these methods and they don't really understand them. So once you run this application, once you do a run and test, and it builds the application, it puts it on the simulated iPhone or iPod, or the iPhone app. It's a simulated app. Once it does that the very first time, it's always there. If you make changes to this database, and I can't emphasize it enough, it doesn't change on the simulator. It won't until you delete the app off the simulator, and then when you run this, where do you go? It doesn't find it on the simulator or on the iPhone. It has to then put it back on by taking it here, copying it, and putting it onto the iPhone simulator. Alright, I hope that's clear. Now, if for some reason it doesn't find it here, we have to have, this is an NAssert class, we have to have something that tells the user, hey, I failed to create a writable database to the message with the message, and the message here will be the error and its description. So if I were to delete this and try to run this, I would get this error message, provided I don't have any copy on the iPhone simulator. Try it. Delete the copy from the iPhone simulator, come over here, delete this for kicks, and run it. And this will pop up. It won't see it on the iPhone simulator, and it won't see it in your resources, so it can't copy it. It'll fail. These are important, very important, and once they're run, they're done. There's no need to run them ever again. You don't need to do them at all. But what you find is that for each class, and we're going to get into this shortly, we may not finish it in this session, but for each data class you create, you run these methods as a check to make sure it's on your iPhone or your iPod. And what will happen is, well, if it's here, okay, you're going to get true, it exists, and it ends. But if for some reason it's not, okay, and the user goes into whatever data class it is, if it's for a list, if it's the list data class, or if it's for the categories that are in the list, there's a category data class, it'll always write the database over from here to the iPhone app if it doesn't exist. And you want to do that. You want to make sure you do that. Okay, so that, as far as our file information is concerned, puts us in a very good state. Alright, next thing we're going to do is we're going to go File, New, and New File. And so we don't overwhelm you here, we're going to go with an Objective-C class right here. It's going to be a version of NSO object. We don't have, and there's no views, or it's going to be a data class. We don't have any view that will be necessary with it. what we're doing with this data class is we're going to use it to extract data from the SQLite database. It's going to be where we do that, and then via the app delegate we will send that or populate that information in arrays in the app delegate, and then the table view or whatever view we have can then access the app delegate for that information. So I hope that's straightforward. Okay, we're going to call this one and this our web data right here, web data. Okay, and we're going to save that. Alright, it creates a .h and a .m, right? And it creates it with a foundation item here, right? We're going to copy the user interface kit over here. We don't typically start from the foundation, but it's easier with the user interface kit to place that in there. The other thing we're going to have to do here, is, I get the right key here, there we go. We're going to run the import, and we're going to import. You've seen us import things with this, right? And then type something in, whatever it is. We're going to do a second import like the first one, SQLite H. Notice it's picking it up in IntelliSense. Okay, we need to import SQLite into this. If we don't do that, we're going to have no access to SQLite from the class. You see, what we're doing here is we're going to extract the information, the data, whatever data we require using this class from SQLite. We're going to pass that to the app delegate. I'm just going to move this up here where it should be. And then once it's in the app delegate in an array of some sort, we're going to then access it to access that data via the root view controller. So it's our way of getting information from one class here to this one through the app delegate. We can't do it directly, it wouldn't make sense. And since the app delegate is what we find, just a second, right here, right? This class here is the app delegate class, and everything that's viewed in here is under the app delegate. So it makes sense for us to shuffle the information through the pipeline, as I've called it earlier. I call it the pipeline of information in the app delegate. Okay, now we're going to need some variables, right? I'm just going to go back to the database in. I'm over here in my web, my YouTube site. Okay, I'm going to minimize that in the back. And the table, you notice we have fields WID, field SName, and field URL. What I need are a couple of methods. I need data to populate a table view. I only need, really, the WSName, and I do need the WID because I need the primary key. I need some way of linking to it and extracting information out of it. Okay? So I'm going to say, in this case, we're going to call it, it's an integer, and we're going to declare it W. Let's see. Yeah, we'll call it WID. Actually, I'm going to do it this way. Actually, integer is reserved. Why not call it, I want to call it something that's different than Alright, we'll do it this way. I want to call it something different than the actual. Here we go. Alright, that's good. Oh, I'm sorry. I want that as a D. Alright, so it's the web ID integer, and then I'm going to call up the string and call the web name. Okay. Apple's naming conventions typically are lowercase on the variable and then the uppercase to identify what it is. This is a string named web name. This one is kind of a reverse of it. For the integer, let me see if I can do it, but I don't think you can. I think integer is reserved. Let's see. Alright, no, it is. It's okay. It was giving me that. Okay. And then here, alright, we're going to have to go a property, right? You've seen this before. Non-atomic, retain. Okay. And this one right here. We're going to just copy this right here. Put it back in. Right. And it's going to say we have to synthesize it. Now the integer we don't have to do that here. It's not necessary. The string we do. The integer, there's no need to declare that. I'm going to show you an example of one of them here. Here's an integer, here's a string, and, well, actually it does a read-only on it. Alright, I take that back. So, well, it's specified as a read-only. I'm going to place it in there. Sometimes I forget about these things, but INT WID. Okay. So these two items then now need to be synthesized. Why was it chosen as a read-only? We're reading this primary key. We're not writing anything. We can't. The primary key can't be changed. In a database, it's a fixed number and it's written automatically. I'm going to go back to that just to show you the database and the structure. It's a primary key. And when we created, for example, this one here, when we added it through here, it's going to add this primary key automatically when we add the text and the URL, which is what we did here. This number is not something you can add or change because it's linked to the record. It's a way of finding that record in a database. Is it related to the record? There's no direct relation to it. Like Google has no relation to one, neither does the URL. But because it is the number of the record or the primary key for the record, if I look for record 1, I will pick up Google and www.google.com. We'll get into database things like normalization, things that will make you better understand the databases once we get this thing on the road. But for now, understand that a primary key, which is, by the way, auto-incremented, the next one will be 2, and then 3, and then 4, you don't add or change it. Hence the reason for read-only. Now, I'm even wondering if you had to do that but I guess we did because we needed to declare it as a property. We needed to know what kind of a number that is. Typically, integers don't have to have any property here, only strings, and there are other ones too. But the bottom line is, we can declare it a read-only. If we go to the other example I had here, here's a whole bunch here. We have some strings and integers and so on. Notice on some of these integers they're read-write, and that is perfectly feasible so long as you can change them. None of these here are primary keys, right? We have this one here. It's it's a number that's going to be called dupli check, a number called cart check, a number called LID. This is the list identifier. It's like a foreign key. You can write it, but you have to make sure it exists. And I'll get into foreign keys later on as well. And this is a total count, and it's a read-write as well. It can be read and written if you wanted to. Again, what we needed was to identify the primary key and the web name. These are the two things from the database we need to be able to look at. Okay. And what we go over here now is we're going to then synthesize here, of course, which should not under here. I'm sorry, I always forget. There we go. Right, and the string web name. So we're synthesized there. At the least, everything is going to drive. They go away. All right. To finish off this part of the tutorial at this point, we need some methods as well. One of the methods is going to be a class method. I'm just going to, whoops, sorry. And class methods are methods that you can run without having to create an instance of the class. So what does that mean to you? It means, look, I need to run a method, and I don't need to have the instance, but I need to access information in the class. That's really what it means. One of our first ones here is going to be getInitialData to display. We need to get the initial data in SQLite to display, and one of the things we need in order to do that is what? This is going to be, whoops, I'm sorry. It's going to be a string. And the database path, right? So, oops, sorry, and a string. And we're going to declare it this way, and we're going to call this database path, right? Oh, sorry. Happens sometimes. Oh. Let me just check here. Right. It should be fine. Oh, I see why I don't have a space. Need a space here. Okay. And whoops, I think this has to be here. There we go. Okay. I didn't have it. Methods have to be before the end statement and after the brace, so your methods will be in here. Okay. This is what we call, it returns nothing. And that's what class methods typically do. They don't return anything. They can return things, but we want to get the initial data to display, and we need the database path to do this. Right? We can't get the data if we don't have the path, because we're going to query the database. And the other one and these are instance methods, is, I just want to go, and I don't remember everything by memory, but is right here, this one. I'll copy it and go over it in a second. Okay, yeah. initialize with primary key, and it returns the ID variable. We'll get into that a little later too, well, after this tutorial, but the ID, not the ID method, I'm sorry, the ID type, it basically will return the primary, it'll initialize and return the primary key when you see that method. So, but you need to specify. So looking at these two methods, what are you going to need? In the method somewhere, the database path here, and in the method here, the primary key will be specified. Alright. I'm going to do the primary key tonight. I'm going to hold off on this one until the next tutorial. And once this one comes in, we'll be able to load up our data. So let's look. I'm going to go again and switch, because I don't remember all of it, but it's one of those things that we need to set the primary key equal to the integer we declared in the beginning, right? So I find it here. Notice all of this SQLite code. Don't get intimidated by it. Here it is, right here. And get rid of that. You don't need that one. Alright. I'm going to copy this over. And basically, like I said, we're setting the the variable we created equal to the primary key. That's all we're doing. It's simple, but sometimes I have to go back and just copy and copy these things. Notice the implementation is going to fail because we don't have the methods there. Okay. And we're also getting an error here. Why? This doesn't exist in the, I'm sorry, in the, yeah, it doesn't exist. Oops, wait, we're in the wrong section here. We should be after the synthesize. Yeah, okay, there we go. Alright, I always forget where things go. Implementation, synthesize, and then all of your methods. This variable doesn't exist. Remember, we synthesize the int, and there we go. Okay, so here, what are we saying here? Initialize anything above using the super, meaning above this class. Initialize it. The self talks about this class, right? Okay. So we initialize anything above it. And then what we do is we take this integer that we declared as a read-only and set it equal to pk in here, right? And we return itself. So what you're going to find in, I'm going to take a peek at it right now, but we won't get into it until, and it's the meat of SQLite. There's a point at which you initialize with the primary key. You have to do that. It's right here. Initialize with primary key, and then the primary key is here. We're going to pick up the primary key from this statement called the select statement. And when we pick that up, it's going to be the 0. It corresponds to the column. So in this case here, you have 0, 1, 2, 3, 4, and so on. 0 happens to be the very first column. It's saying, okay, SQLite 3 column integer, select statement, and 0. Make this the primary key, and then initialize with the primary key. That's what we want to do. Okay, now notice, we had to create an instance of the class, allocate, and then initialize with the primary key. Right? And this is done, this initialize with primary key, it's done, that instance is done within the class method. So you can have an instance method and a class method, right? Okay. When we come back for the follow-up on this, we're going to build this method here for our we're going to go through it step by step for our necessity. And we're going to then put in this whole NS log. We're going to error check it as well. We want to make sure we're getting the right information and so on. So this becomes the meat. What this does is it will extract the information from SQLite, and then once you have it, you notice here too, I'm going to quickly look at this, the app delegate comes in, and there's an array there, some sort of array, and we're going to add each object we pull up in here to it. So in this case, the list object is for the item name, let's say. We'll pull that out from column number 1 here. And once we have that, we're going to add those objects to the array, and then of course release the object. And now the app delegate will have the information. So we're going to use this to pass information from SQLite to the app delegate. Okay? So again, to recap tonight, now this is going to give us an error here. It's going to say incomplete implementation. It's true. Why? We haven't done this class method yet. So what did we do? Alright. We created the methods that we need, to copy the database over from the resources here to the iPod iPhone, or if it's in the iPod iPhone, check to see if it's there. Make sure we have a database. And then when we do that, we then created two classes here to hold on to this web data. Created an integer, a string, which will be equivalent to our primary key and our web name field. Synthesized, or created the properties, I'm sorry. After the properties were created, we synthesized here. Pardon me. We created a getInitialDataToDisplay method and an initialize with primary key method. The primary key method basically picks up the primary key variable here, which we'll see later is going to be extracted from our select statement, and uses this then in the select statement, or in the getInitialDataToDisplay method to initialize the object with the primary key, thus allowing us to get information from it. So when we come back in the next tutorial, we'll finish up with this, and you'll be able to see exactly the data will be populated in the table view. We'll no longer have a need in the root view controller. We'll no longer have a need to declare. We don't have it here actually, but we have no need anymore to declare a mutable or even static array. Alright, so I'll see you next time for SQLite tutorial number 3, where we build the select statement, we link it, or we pass the information to the app delegate, pass that information to the table view, and display it.